This is one of a series of Good Answers presentations, offering evidence to answer skeptical challenges to the Bible's accuracy. Today we will look at one of the biggest questions on earth, or rather, about Earth. How old is our planet? Here's a concise statement of the issue. The age of the Earth has been a matter of interest to humans for millennia. The subject is still debated today, particularly between young Earth scientists who believe that the Earth is only approximately 6,000 to 10,000 years old, and most scientific organizations who believe that Earth is approximately 4.5 billion years old. Now, this way of stating it suggests that this is a Christians versus non-Christians issue, but it's not, of course. Those of us who believe that there is an all-powerful Creator who brought the universe and all life into existence do themselves differ about how long it took. Either it was done in 6 days or over an immense stretch of time. Rather than debate the two views, we may content ourselves with saying that God did it as He saw fit. Or we may choose to examine the scientific evidence in hope of determining which of these scenarios is the more likely. But some may ask, why does it matter at all? For Christians, I would say that it matters because it determines how we understand a major portion of the Bible. Consider this. If the earth is young, then the first 11 chapters of Genesis can be read straightforwardly. First, the creation took only 6 days, as the text says. There was evening and there was morning, the first day, and so on. Second, Adam and Eve were real persons, not myth, allegory, or symbol. Third, the account of the Garden of Eden, temptation by Satan, and the first sin are literal history. Also, the genealogies in those chapters are, at least in the main, accurate records of families. And last, the flood of Noah was a worldwide catastrophe, leaving the earth as we find it today. If, on the other hand, the earth is old, then one has to read these chapters of Genesis other than literally. There are numerous ways of doing that, such as theistic evolution, in which God directed the process of evolution, or the gap theory, where long ages separate the first and second verses of Genesis chapter 1, or the day-age theory, where each day of creation is ages long, or progressive creation, in which God creates portions of the ecosystem in short bursts over countless centuries, or the framework hypothesis, where days 4, 5, and 6 are seen as the same as days 1, 2, and 3, described from a different perspective, and so the account is poetic or metaphorical. It is, I think, important to note that nearly all of these long-age theories were developed in response to the appearance of evolutionary theory. None of them were needed until Christians felt they had to accommodate Scripture to an atheistic scenario. It's interesting, though, to see how opinions of the Earth's age have changed. For much of our history and in many cultures, it was assumed that the Earth was around 5,000 to 7,000 years old. Then in 1778, the Comte de Buffon concluded it was 10 times or so older than that. Buffon, a naturalist and mathematician, has been called the father of all thought in natural history. With him, the race was on into the uncharted past. Less than a decade later, Abraham Werner, so-called father of German geology, opted for 1,000,000 years. Just a generation after that, Georges Cuvier, the first modern paleontologist, assured us that long ages were involved. In another couple of decades, Charles Lyell pronounced the Earth to be millions of years old. The author of the landmark work Principles of Geology, he popularized the idea of uniformitarianism. Half a century later, the Earth became far older, as Lord Kelvin pronounced it to be between 20 and 100 million years. A mathematical physicist, Kelvin was first to determine the temperature of absolute zero. Then we get into the 20th century with Arthur Holmes, a geologist who gave us radiometric dating and plate tectonics, and a much older Earth, 1.6 billion years. And then geochemist Claire Patterson gave us the number we still hear today, 4.5 billion years. Well then, that's quite a roster of scientists who have given us an old Earth. What are the scientific reasons that convince them? Here are some of the best-known ones. The great depth of sedimentary rock, in layers adding up to miles in some places. Then there is Arthur Holmes' contribution, radiometric dating of igneous rock, giving us billions of years. For shorter periods, but still too much for a young Earth, there is carbon-14 dating of various organic substances. We must consider fossil fuels, coal and oil, the remnants of plant and animal life from long ago, and coral reefs, which grow very slowly. Stalactites and stalagmites are also clocks, as seen in their growth. And we have clocks of sorts in ice, with the glaciers of Greenland and Antarctica. And finally, we see the trees that time has turned to stone. Lots of clues to tell us of a long history for our planet. Before we examine each of these, however, it's important to note something about science. We're often assured that science tells us about the distant past, and it does, but in a particular way. There are, you see, two kinds of science. There is observational or experimental science, and there is historical science. They are quite different. Experimental science takes place in a laboratory. It deals with the present, what is true now, and it uses first-hand and test-based experimentation to determine it. Therefore, it's repeatable, and it yields actual, verifiable proof. For example, will oxygen and hydrogen touched by a spark yield a bang and water vapor? Anybody with the basic tools anywhere in the world can test that. So we say it is self-validating. Historical science, though, deals with the unrecoverable past. After all, we can't repeat a unique past event. As such, we must reconstruct it from clues, and our investigation will only yield probability. We use historical science when we ask whether the suspect committed the crime. There may be various kinds of clues, blood traces, fingerprints, DNA, even video, but all of these must be interpreted. Somebody has to decide whether the clues give us slight probability or virtual certainty, but never absolute proof. That's why we have courts and juries. So then let's look at each of these evidences for an old Earth. Each of them is a clue for what happened in the unrecoverable past. How good are those clues? First, Sedimentary rock. Most often it's formed when flowing water deposits sediment and then hardens. Very common, it covers some 70% of the Earth's surface in layer after layer. Some of these deposits are huge, like this one, and the strata, layer after layer, may be up to 2 miles deep, as we see in places like Grand Canyon. There is no way to explain the accumulation of so many layers of sediment, unless, perhaps, there was a global flood that remade the landscape. Well, Noah's flood might have produced all that sediment, but it takes millions of years for it to harden into rock, right? Perhaps not. Recognize this? It's a clock mechanism, maybe around a century old. It was found in 1975 by Dolores Testerman near the South Jetty in Westport, Washington. It is pretty solidly encased in perfectly good rock. We don't need long ages for that to occur, and there are many such examples. We hear a lot about radiometric dating of igneous rock, but many people have only a sketchy idea of how it works. Here's one example: uranium to lead. Uranium, U-238, is an unstable element, and over time it decays into lead, Pb206. Scientists refer to uranium as the parent element here, and lead as the daughter. How long does it take? We're told that its half-life, the length of time it takes for half the uranium to decay into lead, is 4.47 billion years. So, in the illustration here, if the rock on the left contained 10% of uranium and no lead, after about 4.5 billion years, it would contain 5% uranium and 5% lead. So we have a clock, one that measures vast ages of time. But the clock may not be as reliable as it sounds. For starters, we don't know how much of each element was there at the beginning. Was there only uranium present then and no lead? Or was some lead present too? Nobody was there to test the rock, so we don't know. We also don't know what happened in those years when the rock lay in the earth. Could some of the uranium have been leached out by groundwater, or some lead introduced in the same way? That would throw off the clock. And finally, do we know that the decay rate of uranium has always been the same? Modern testing has raised questions about whether that rate is invariable. 3 problems, each of which can throw off our clock. Scientists must simply assume that none of these ruined their calculation. This is quite a bit to digest if it's new to you, so here is a homely illustration. Let's say you go into the bathroom to freshen up, and you see that the water's running in the tub, which is now half full, 10 gallons. You note that the faucet is running at 1 gallon a minute. So, how long has it been running? Easy. 10 minutes, right? Oh, but you hear a noise in your brother's room. Look in and see that he is mopping up some kind of mess. Seems he dipped 1 gallon out of the tub for the chore. So that changes the terms. Now the faucet's been running for 11 minutes. But just as you reach this conclusion, Mother shows up in her robe. It turns out she was running the tub for her bath. But she says she had the tap on full blast, a rate of 10 gallons a minute, until the tub was half full. Then she cut it back to 1 gallon a minute when she went to get her robe. So now the math shows us that the faucet has only been running for 2 minutes. As you see, we have to know those 3 items: initial composition, any change along the way, and whether the rate was constant. Otherwise, we can get it wildly wrong. Radiometric dating involves too many assumptions. But how about carbon-14? Well, there's a cycle there that goes like this. Normal, stable carbon is C12 with 6 protons and 6 neutrons. C14, which is unstable and subject to decay, is made in this way. The nitrogen atoms in our atmosphere, N14, have 7 protons and 7 neutrons. If any one of those atoms is struck by cosmic rays, they may convert one of the protons into a neutron. That leaves just 6 protons, which makes it carbon, but an unstable variety, carbon-14. So then, our atmosphere will include both C14 and C12. The ratio between them is about 1 part per million. Here's where it gets interesting. Plants, as you know, take in CO2 from the atmosphere and release oxygen, the exact opposite of what we do. The carbon, a mix of C14 and C12, remains in them. Animals eat the plants, and some carbon remains in their tissues. Then plants and animals die. Up to that point, the ratio of C14 to regular carbon has been the same as that in the atmosphere. But once they die, they stop taking in more of it, and the C14 continues to decay. Let's watch that C14, which has a half-life of 5,730 years. In the 1940s, Willard Libby realized that if we determined the concentration of C14 left in plant or animal remains compared to the ratio in the atmosphere, we'd know how long ago they died. His method has been refined since he invented it, and now it's said to be able to detect an age of up to 100,000 years. C14 is a very valuable tool, but it has its limits. If the Earth's ecosystem had been stable throughout history, we could perhaps trust that 100,000-year clock. But if there had been some major disruption in atmosphere, plant, and animal life, C14 dates from before that disruption would be thrown off. And as Christians know, there was just such a catastrophe once. So we can trust C14 up to around 3,000 years or so, but not beyond the flood. But there are other clues suggesting an old Earth, such as coal and oil. We're told that they date from the Carboniferous period, somewhere around 300 million years ago. As plant and animal remains decay under certain conditions, they may be converted into these fuels. But long ages are required for the process. Or are they? Not so. Here's what we know now about coal. Lab experiments have shown that heating wood to 150 degrees centigrade can turn it into coal in a matter of weeks. That's from Argonne Scientists Make Artificial Coal in the Chemical and Engineering News, and also in Science News. But how about oil? Much the same. Oils have been shown to be produced within hours and by no means require millions of years to form. Commercial thermal converters routinely turn animal slaughterhouse wastes into high-quality oil and fertilizer in 2 hours. And not only can it form quickly, it has a limited lifespan. Oil quickly degrades from bacterial action, since it is an organic compound, unable to survive for millions of years. That's Tim Clary, Ph.D., from Rapidly Forming Oil Supports Flood Time Frame. Coral reefs are proof of great age, aren't they? Here's what National Geographic says, quote, "Some of the coral reefs on the planet today began growing over 50 million years ago." But have they? Here's another quote. "More accurate measurement of these rates under favorable growth conditions now show us that no known coral formation needs to be older than 3,400 years. That's Dr. Walt Brown in his book, In the Beginning, Compelling Evidence for Creation and the Flood. If you've taken a tour of almost any cave, you will have heard the guide tell you about how very slowly stalactites and stalagmites grow. They usually mention hundreds of thousands of years. And yet, here's a chart published by the National Speleological Society. Researchers monitored growth over decades and found numerous examples with growth rates averaging over half an inch per year. That would allow some 180 feet of growth since the flood. I've never seen a stalactite that long, and I'll bet you haven't either. Well, let's leave the caves and visit a glacier. The common wisdom about them is expressed in this Britannica article. Because there is no melting, the layered structure of the ice preserves a continuous record of snow accumulation and chemistry. Actual samples of ancient atmospheres are trapped in air bubbles within the ice. This record extends back more than 400,000 years. That's Britannica.com, as you see. So, season after season, century after century, the glacier gradually builds up and preserves a record of remote antiquity. Very slow accumulation, right? Sounds good, and I found it persuasive until I came upon an awkward fact named Glacier Girl. Here's what happened. In World War II, we ferried countless warplanes over to attack Hitler's fortress Europe. They typically refueled for the long flight at air bases like Thule in Greenland. Well, one flight of 5 P-38 fighters lost its way in 1942 and had to land on a glacier. The pilots were rescued, but in the press of events, the planes were left. Over a generation later, some veterans who learned about the lost squadron got the idea of retrieving it. The project leader had this to say, quote, "All we'd have to do is shovel the snow off the wings, fill them with gas, crank them up, and fly them off into the sunset. Nothing to it." They did indeed find the planes in 1988, under 250 feet of ice. After thawing their way down to one of them, they were able to retrieve it in segments and transport the parts back to Tennessee. Some years ago, I visited the site where they were restoring the fighter, and not too long after that, Glacier Girl actually flew again. I find that a feel-good story, but we shouldn't lose a salient point here. In 46 years, that glacier accumulated 250 feet of ice. Very, very slow accumulation, right? Oh well, there's one more major argument for an old Earth that I had mentioned. petrified forests. There is hardly a better example of these than Specimen Ridge in Yellowstone National Park. When I was there some years ago, it was high on my list to visit that site. But the Yellowstone River was in flood, and we couldn't get to it. Fortunately, though, there are substantial publications about it. We're told that it consists of some 27 forests layered on top of one another, representing millions of years of growth, death, decay, and regrowth. Anyone seeing those petrified stumps, layer after layer of them, could easily picture the long ages in which whole forests grew up, died, were petrified by minerals in the groundwater, and then buried under new forestation. When Dr. Mike Arkt got permission to study the site, however, he made a fascinating discovery. Knowing that ring patterns in mature trees record year-by-year growing seasons, he looked for patterns of good and bad year growth that would show a pattern of seasons. Quote, Dr. Mike Arkt discovered a signature ring pattern in several different layers, demonstrating that the various forests grew at the same time and must have been transported to this location on successive mud flows, thus disproving the consecutive forest model. That's Dr. John D. Morris in The Young Earth, page 115. So, not 27 forests from 27 eras, but evidence suggestive of massive flooding over a short period of time. Perhaps the flood of Noah? Dr. Arkt's discovery had at least one result. The Park Service quietly removed the sign that talks about the evolutionary long age explanation. Well, time for a box score. What clues do we have for a 4.5 billion year old Earth? Great depth of sedimentary rock? We have that all right. But a global flood explains it quite well. Radiometric dating of igneous rock? Fine, so long as we can know the original composition of the rock, whether contamination occurred over its lifespan, and whether atomic decay rates ever change. And the millions of years age readings on lava flows that occurred only decades ago also suggest that we can't trust that method. Carbon-14 dating of bone, wood, and so forth? An excellent tool for anything up to 3,000 or 4,000 years old, but not beyond. Coal and oil? They can be made within hours or weeks with conditions that can occur naturally today. Coral reefs? They grow faster than the evolutionists claim. Stalactites, stalagmites? Same there. Mile-deep glaciers? A P-38 named Glacier Girl should make us reconsider how quickly they can build up. Petrified forests? Not since Dr. Arkt found they share a signature ring pattern. Remember when we began this survey? The age of the Earth comes under historical science, not observational science. The unrecoverable past has to be reconstructed from clues, and the clues must be interpreted. This survey suggests, I would submit, that we may need better clues for the age of the Earth. For some more clues, take a look at Part 2 of this subject. Until then, think it over. Maybe our planet is not that old, after all. If you have questions or comments about this lecture, or any of the others in the Good Answers series, you may address them to me, Dr. Jerry C. Four, yahoo.com.